response, or what would you like to do? Are there particular questions that you want me to look at first? I want to go back to exam one. It's hard for me to say, focus on this, focus on that, because like everything is. Everything is on it. Like, so you'll have question number one here, where you have to find the electric field. You're not going to find the potential in the free response, but you will have to find the electric field, just the magnitude and direction. I did that in class yesterday. Is that something you want me to do again here? Yeah. All right, let's do it. You'll have to do this in the exam too. We'll look at some that are like that. This is probably the class or the exam that you miss the most. So to find the electric field here, I first want to draw my vectors. And remember, to draw your vectors, you imagine a positive charge and ask if the force is attractive or repulsive. And then the electric field will be in the same direction as the force. So at point A, for example, I imagine a positive charge right there. A positive charge would feel an attractive force to Q1. So we'll call that E1. Remember, the force and the electric field are in the same direction. So I imagine the force, and then that's also the direction of the electric field. And then E2, that is the force due to Q2, is going to be in that direction. So that's E2. Then I need to calculate the magnitude of each of those. Or I also want to calculate the angle. So I need to know what this angle is. I do the inverse tan of opposite over adjacent. That's 4 over 3. That's 53 degrees. All right, so that's my angle is 53 degrees. Then I calculate E1 and E2. So E1 is 9 times 10 to the 9th times Q1, which is 25 times 10 to the minus 9. Remember, whenever I'm dealing with vector quantities, I don't put the sign of the charge, because the sign of the charge is accounted for when I draw that vector. And then I divide that by r squared. The distance from here to here is 5 meters, and so that's 5 squared. Likewise, you'll have a similar setup. I just really like having the 3, 4, 5 because it's familiar to you. You don't usually have to calculate the angles and stuff. So you will have a 3, 4, 5 setup like that. The charges can be anywhere along, but you will have it such that one vector is off axis like this. So it'll be a lot like this one. And similar to this one, it'll be such that a lot of the numbers will cancel out. So write it out like this, and you see our 25 cancels there, and that cancels, and it just leaves me with 9 newtons per coulomb. And then in a similar way, I can calculate E2. That's 9 times 10 to the 9th, 16 times 10 to the minus 9, divided by 4 squared. That cancels. Oh, so both of these are actually equal to 9 newtons per coulomb. So this is equal to 9, this is equal to 9. And then after that, I like to redraw this as another picture, a free body diagram, where I have 9 newtons per coulomb here, and then I have a vector there and a vector there. Those are going to be the components of this vector. So that's going to be 9 sine of 53 and 9 cosine of 53. That's 5.4 and 7.2. And once I get that, if you've drawn the picture, then it should be pretty apparent how to add up those vectors. I draw it again at 5.4 right there. And then here, I'm going to do 9 minus 7.2. Or rather, it's actually going to be 7.2 minus 9, which is negative 1.8. And so I have this 1.8, which is in the downward direction. Now we're almost there. I know that my vector is right here. Define the magnitude. I do 5.4 squared plus 1.8 squared. That's whatever it is. And then define the angle. I'll call it phi. I do the inverse tan of the opposite over the adjacent. That's 1.8 over 5.4. I have a new calculator. I don't know how to do it. Anyway, that is whatever it is, that angle. However, that angle, recognize that you'll need to define it. So whatever that angle is, it would be below the negative x-axis. Okay? So that'll be one question. I'm not going to ask these other things about the potential, but I'll ask those two things. I'll be looking for the magnitude and the angle and the axis that the angle is measured from. You'll also have questions in the exam that have to do with electric field and electric forces. Like there's a question like number 1. There's some variations of that too, where you're finding these are qualitative questions or conceptual questions about that. Likewise, where is there another one? Like number 7 or number 11. Like there are questions there that are about the electric field and electric force, but in a conceptual way. Are there any particular questions from this exam that you want to look at? This is exam 1. No particular questions? No? All right. Do you want to? Nothing in particular? Have a question? This is spring 25, yeah. You want to look at spring 26?
I just have spring 26 pull up.
Okay. Yeah, let's pull up spring 26. I'm sorry. So the way I would approach studying is I would look at each exam individually and just work through it, set aside about 40 or 50 minutes to work through each exam. And if you do well on each exam that you do, I mean, that's going to take you 3 hours, 3 or 4 hours to do that. But if you do well in those exams, then you're probably okay. But if you do poorly on any of them, then you want to go back and focus on those exams. All right. All right. Particular ones on this one? Said, I mean, they're all on there. I picked out 10. I tried to get a good sampling of them so that, like, if I have multiple questions that cover the same topic, I will weed out some of those questions. All right. All right. Well, let's look at exam 2. So I can do the free response, and then we can look at the multiple choice in those too. So from exam 2. You have a question that's like this, where you have a circuit that is, and you have to find the voltage and the current, a voltage across one of the resistors and a current through the resistors. You'll have to do the whole circuit in order to determine that. But so I like to do this in steps where you start just by simplifying the circuit. I have that 2 ohm resistor, this 3 and 6 simplify to a 2 ohm resistor, and then the 3 and 3 simplify to a 6 ohm resistor, and then I have this 3 ohm resistor here, and that's all 12 volts. As I told you in class, the battery is actually, it has 18 volts, just the way the voltages were distributed. So don't be thrown off by that. The 2, 6, and 3 now are 1 ohm. So I have a 2 ohm and a 1 ohm, 12 volts. And then I find I can simplify that to just a 3 ohm resistor, 12 volts. That means that I have a current equal to V over R. That's equal to 4 amps. So I have 4 amps there and 4 amps there, because resistors in series have the same current, and they have the same current as their equivalent. So if I have 4 amps, that means I have 8 volts, because V is equal to IR, 4 times 2, and here I'd have 4 volts. Remember, you can do this distribution, how the voltages are distributed across resistors. Remember, with resistors, the big resistor has the big voltage, the small resistor has the small voltage, but it was separate, it was opposite for capacitors. So if I have 8 volts there, that means I have 8 volts here. It means I have 4 volts here, 4 volts here, and 4 volts there, because resistors in parallel have the same voltage. And then if I have 4 volts, that means I also have 4 volts here and here. That's 4 volts there, 8 volts here. And then I have 4 volts across those two 3 ohm resistors, but because they're identical, they split it up evenly. So that's 2 volts and 2 volts right there. All right, so once I get all the voltages, then I just go back and pick out the ones. You will need to find them all because I picked the ones that are embedded. So for R2, the voltage is 4 volts. And for R4, I'm looking for the current here, but current is just V over R. So for R4, I know that it's 2 volts divided by 3 ohms, or 2/3 amps. All right, so those are the answers for that one. And you'll see circuits like that in the free response as well. But you're going to see a capacitor circuit in the multiple choice. You're going to see a resistor here where you have to calculate the resistance in the multiple choice. So yeah, you're going to, yeah, like, so for example, number 4, 5, and 7, and 6, like those are all similar. So you can bet pretty sure that you're only going to see probably 2 of those that are really similar to one another. I don't always do these really simple ones like number 8. I don't usually, number 8's not on there, so I tend to not do those. Honestly, it's kind of hard to weed out questions. So not that I get rid of all the simple ones, but I don't do usually units like that. All right, you'll certainly see relationship problems like number 11, where, let's just do number 11. I have resistance. Resistance is rho L over A. Always write the equation when you encounter one of these questions. If I quarter, I make the cross-sectional area 1/4 of its original size, 1/4, and then I also have the length. That means that the resistance is going to be 1/2 over 1/4. That's 4 over 2. So it's going to be twice as big. What I did is I did the 1/2 divided by 1/4. You can do that in your calculator if you want, or that's the same as 4 over 2, which is equal to 2. Actually, that question is on your exam. Let me tell you, I don't say area. Instead, I say what happens if you change the diameter. So like say, for example, I said that I doubled the diameter. That would mean that, well, I'd write R equals rho L over A. If I double the diameter, what am I doing to the area? Not twice as big, but what? 4 times as big, right? So if I doubled the area, 2A, or excuse me, if I doubled the diameter, that would lead to 4 times the area, because the area is equal to pi r squared. It's proportional to the diameter squared. Is that clear, what I just said? Yeah? Okay. That is on the exam. Yeah, you're going to see some of these, like I said, number 13 and number 19 and 17 and 20. Those are all really similar, so you'll just see 1 or 2 of those. But, you know, every question is important. Any particular questions from this one, Yo? No? All right, let's go to exam 3. We can come back to any of these. Listen, a good way to study is if you find questions that are just difficult, that you're uncertain about. What are you doing, exam 3? That you can go back and look at other past exams of that same type and get a feel for, you know, how I change those questions. That'll give you extra practice, because you're not going to see exactly the same question. You're going to see a variation on that question. But looking at those other past exams will help you to do it. So really, I mean, I say you need 3 or 4 hours to work through all the practice exams, but really, if you're having trouble on those, you might need 8 to 12 hours to prepare for the final. So just beware that there's a lot of work that needs to go into this exam, especially if you're struggling with some of the material. Okay, so I'm not going to do the numbers here. I'll just write the equations. We did this in class. But I'm asking first, what is the direction of magnitude of the magnetic field? So the magnetic field is equal to mu naught I over 2 pi r. And so you'd calculate that. Here, this is R. I is 4 amps. And mu naught is that 4 pi times 10 minus 7. That's on the equation sheet. You will have a full equation sheet. You'll just be able to tear it off, so you'll have it right next to you. As I said in class, I have the wire not like this, but I have the wire that is either into the page. If the wire is going into the page like that, that would mean that the magnetic field would be up, right? I let my thumb go in the direction of the current, and then it folds around. So over here, the magnetic field will be up. If the wire was out of the page, I let my thumb go out of the page, and then on the left-hand side of the wire, the magnetic field would be down. So you'll see a wire that's like that. We don't usually do it that way, but I don't know. That's just the way we did it this time. Okay? After you find the magnetic field and the direction, you have to get both in order to get full credit. You have to get both correct. For part B, to calculate the force, it's just QVB. It will be orthogonal, so you won't have to worry about the sine theta term. And then you calculate, or you find the direction. Let's see, in this case, the magnetic field was into the page, right? So I have a velocity that's in that direction, a magnetic field that's in that direction. So that's V. V is into the page, so the force is up. Okay? You will see several right-hand rule problems on the exam, so make sure that you understand the right-hand rule. It comes up several times. You'll see a question where you have to find the charge or voltage or current on a charging or discharging capacitor. You're going to see a question like number 2 where you have to ask, are these equations correct or not? And you will have to calculate the current in a multi-loop equation. It'll be a simple problem. It'll just be a one-step problem, but you'll have to do that. It's sort of like where I have number 2 and number 3, it'll be like that, where I have a circuit, you find the right equation, and then you also find one of the currents in the circuit. Are we good on that? Okay, y'all speak up if you want me to work something. All these are fair. Pretty sure I'll put one like this, number 10. Students sometimes have trouble with that, where you're taking the words and you're putting them into the form of a diagram. So here the cation, or a positive ion, travels in the plus x direction, so V is in that direction, and the magnetic field is in the z direction. That's like B is like that. And then you have to use your right-hand rule to find the force. That would be, of course, down. So the force here would be down using your right-hand rule. There will be a place where you have to, find the force. Well, that was in the free response, but I'm pretty sure I have a multiple choice question like that too. All right, and then about light, calculate index of refraction, reflection of light, draw the rays, those sorts of things. All right, particular questions on exam 3? Okay, let's look at exam 4. Y'all haven't studied that much yet, have you? Study that much? Oh, that's okay. We're still a few days out. I'm sorry we can't have a help session tomorrow. All right, what was your number 3 was your free response? Oh no, number 2 and 3 were free response. Is that right? What was the free response on this one? Was it just number 2? Yeah, okay. I know number 2 is on there. So you will have a mirror question. and it'll be very similar to this. The first thing you need to do is just determine what type of mirror it is. Make sure you know those 4 scenarios for the mirrors. I mean, you need to know them for the lens too, but for the concave mirror, there were 3 situations: outside the focal point, at the focal point, and inside the focal point. In this case, the image is there. That's the image. This has no image, and here the image is there. And then for the convex mirror, there's your object, your image is right there. So question is it upright or inverted? And is it bigger or smaller? And if you know those 2 things, then you should be able to tell what type of mirror it is. In this case, it is upright, so it gets rid of that, and it gets rid of that. It won't be a no image, you'll have an image. So it's upright, and is it bigger or smaller? The object is 6 centimeters tall, and the image is 2 centimeters tall, so it is a convex mirror. So that'll be your first step, is just determining what type of mirror it is. In this case, it was really important because the focal length of a convex mirror is negative. Center of curvature is 40, so that's negative 40 divided by 2, or negative 20. So that's our focal length, and then our magnification is negative Q over P. Our magnum is HI over HO rather. Our magnification is positive 1/3. Positive 2 over 6 or positive 1 over 3. And now that I have that, I can set up my system of equations. I have 1 over negative 20 equals 1 over Q plus 1 over P, and then also negative Q over P equals 1/3. All right, I'm going to cross multiply. I get P is equal to negative 3Q. Take this and plug it in for P. Actually, in your exam, the way it works out is that you will not be solving for P in that equation. You'll be solving for Q. You follow what I'm saying? You just cross multiply is all you do. So you just cross multiply on that, and then you'll plug in the whatever it is, you'll plug into the lens equation. So once I do that, I can solve. I get negative 1 over 20 equals 1 over Q minus 1 over 3Q. And then you can solve that for Q. Okay? And find a common denominator. It would be 3 over 3Q. So I get negative 1 over 20 equals 3 minus 1, 2 over 3Q. So that's 40 over 3. Negative 40 over 3. I think it was 13. Yeah, 13 point something. Okay? Being able to do that, that's the algebra is the hard part on that, just being able to do the algebra. In fact, you know, in this exam, I think several of the things are really just knowing how to do the math. The physics is important, but that's really the conceptual stuff of the physics really comes more into the multiple choice. But on these free response, I want to see that you understand how to do the math part of it. That's important too. Know those types of images. You will have a 2-lens system. Okay, you will have a diffraction grading like number 14. I think in the one that I asked, I think I was looking for the angle, if I'm not mistaken. But it's similar to this, where you're just solving for either D, theta, M, or lambda for one of those. But I definitely have that. A lot of y'all missed number 19, so you will have number 19. That was that was the most missed question on the exam. Yeah. Can I say number 19 too? Yeah, while we're here, and then we'll go back to that. Yeah, many people missed number 19, and I was kind of disappointed. When you have them offset that way, when you have total destructive interference, they are offset by half a wavelength. Okay? Is that clear? I put that question in the exam. I'm pretty sure I put that exact question. Don't get it wrong this time. How many wavelengths? Half. Okay? Let's look at the diffraction. It does come up a couple times, once or twice, but there's definitely this one in it. I I think in the problem that I gave you, I actually gave you, we'll do 14 and 15, because I don't think I gave you the spacing. Instead, I think I gave you this number. But we'll come back to that. Let's do 14 first. So D is equal to 2 times 10 to the minus 6. And theta is equal to 24 degrees. And M, that's the order number, is equal to 2. It's the second order, so that's M equal to 2. And I'm just looking for lambda. So I say D sine theta equals M times lambda. That's 2 times 10 to the minus 6 sine of 24 equals 2 times lambda. And I solved that for lambda. I don't remember what that answer was. Was it 324? Do you recall? Was it 324? Yeah, so that's equal to 324 times 10 to the minus 9, 324 nanometers. Okay, let me check something on that, because I'm pretty sure in the question that I gave you, I don't give you the separation. Is the answer D? Oh, yeah, then it's, yeah, I wasn't calculating. It's just 407. Yeah, I'm sorry. Yeah. I say a diffraction grating has so many lines per centimeter. At what angle, blankety blankety blank, is the maximum? All right, so your question will be a little bit different. It'll be a little more complicated, that you'll also have to do this step for 15, where you first have to find the slit separation. I'm not going to give you the slit separation. Instead, I'll give you something like number 15. And you have to calculate the slit separation. That's 1 over 2,500. That's in millimeters. That's 0.0004, which is equal to 0.000004 meters. This is in millimeters, but you have to convert it to meters. So you'll have to do that step on that one multiple choice question, okay? And then use D to figure out whatever it is that you're looking for. In the question that you'll have, you're looking for theta. Y'all know how to find theta? You say sine theta equals M lambda over D. I just divided both sides of this by D. And then to solve for theta, I say theta is the inverse sine of M lambda over D. That's how you find for theta. Okay? It's a different order. I forget the order I gave you, but it's a different order number too. Is that okay? Yeah. All right. There's no double slit, like number 18. So there weren't that many from chapter 8 because we didn't spend a whole lot of time on chapter 8. So, okay. Other particular questions? You just skim through your exam, see if there's anything else. You will have ray diagrams where you have to say if they're correct or incorrect. In fact, if you find something that was in the free response that's now not in the free response, then I'm going to focus on that. You'll definitely have those things. Okay. Anything else, y'all? Y'all look pensive. Are we okay? You feeling okay? Nervous? Don't be nervous. Be prepared. That's always the antidote to anxiety, is preparation. Is that true? I think that's true. All right.